Good morning, everyone. I'm here today to talk about how and why we moved from a commercial DPI library to nDPI, which is the open source deep packet inspection library made by ntop. I am Ivan Nardi, and I'm working at I2M, which is a small company where we develop software for big data retention system and for voice and metadata analysis. I'm working on all the lower level stuff, such as network probes, deep packet inspection, system performance analysis, and so on. And I'm helping Luca and Tony to maintain the nDPI package. Let's start with a little bit of history, just to give you some context. We began in 2005 when we started to write a DPI library in-house, completely from scratch, to filter some kind of traffic. There were no open source library. OpenDPI will be released only 5 years later. At that time, the two most important protocols were DNS and plain text HTTP. HTTPS and encrypted traffic in general was quite rare, and it was used mainly for banking stuff, credit card transaction, and little else. For example, until 2009, the login page of Google Mail was served over plain text HTTP. In 2011, we switched to a commercial software because we weren't able to cope anymore with all the work needed to keep the protocol dissector code up to date. And since then, we use the commercial library plus some custom code that we use for some specific protocol or for protocol stack or for extracting some metadata, for example, from DPI, diameter, authentication stuff usually. All of that happened before nDPI. nDPI was released in 2012. We tested the first release, but it was too simple, and we pretty much ignored it for a few years until we rediscovered it after seeing a Luca presentation at the Shared Feast, and we discovered that nDPI became a more valid and effective product, and we started using it for internal tests. Like we will see in a few moments, there aren't a lot of DPI software, so having another one is always useful. We have been using the same commercial software for more than 10 years, and we were happy about that, but in the last years, we faced two major issues. The first issue was QUIC. QUIC is a new transport protocol, and I must be extra polite here, so I'm only saying that QUIC support in the commercial software has never been as good as we wanted, even if we complain a lot about that. In the beginning of 2020, we had enough, and we wrote a new QUIC dissector code completely from scratch to have full capabilities of classify, sub-classify QUIC traffic, and to be able to extract metadata. In August of the same year, we published that code, upstreaming it on nDPI, and that was the first significant contribution that we made to the project, and likely still is the contribution of which we are more proud. At the beginning of the last year, the vendor told us that they were going to drastically change license terms, not only license fees, but also features and software availability. So it was time to start looking around for another software. we discovered pretty much soon that comparing the DPI engine is hard. And it's hard for a lot of reasons. The first reason is that there aren't so many choices. As far as we know, there are only 30 companies that provide you commercial software for DPI, Sandvine, Rode Schwarz, and Cosmos. What about the open source community? Well, there are two reasons because why nDPI is the best open source DPI software. The first reason is for its own technical merit. It's a good software. Easy. The other reason is that there aren't any other viable option out there. And that's a little bit sad in my opinion, but it's the truth. There are some projects, some of them are even interesting, but none of them have been updated for a few years. And we didn't want to switch to a new software where we needed to do all the maintaining work by ourselves. We have been able to find only 2 academic papers about DPI tools, one from 2 years ago by some researchers at the Polytechnic of Torino, which compare only the DPI, only the open source engines, and the other one is even 8 years old, comparing one commercial solution to the open source solution available at that time. So there isn't a lot of public data out there. There is a blog post by IPOC. IPOC is a Rode Schwarz company, and that post talks about commercial versus open source DPI. It is interesting. You have to take it cum grano salis. I mean, it has been written by their marketing department, so okay. But there is some interesting topics in it. Comparing DPI engines is hard also because different engines have different ideas about what is a protocol, what are the protocol names, and what is a classification or a subclassification. So if you need to compare the results of different software, you have to standardize their outputs, and to do that, you have to do a lot of manual work. Some examples: TLS, HTTP, and HTTPS are basically the same things, but these 3 labels are used in different ways by different engines. For some important application, like Facebook, you usually have some kind of a sub-classification, but each software gives you different sub-classification of protocol lists. Even if there are different apps, for example, Skype and Teams, at the network layer, you may be not able to tell one application from the other. And different software, different engines pick up different names for the same traffic. Some libraries keep using the old protocol name, even if the application changes its own name over the time. For example, Google Hangout, Google Chat, and so on. It's basically always the same stuff at the network layer. One engine keeps calling the encrypted traffic SSL, so you have that classification. Another important topic is the ground truth. I mean, how you know the right classification of your testing traffic. Only if you know the truth, the right classification of your traffic, you can able to tell if the engines, if the software give you the right or the wrong classification. Know the right classification may be easy in some cases. You simply open the pickup with Wireshark and you look at the traffic. Easy peasy. In other cases, it's definitely much harder, especially if you didn't capture the traffic yourself. How you set the ground truth of your testing traffic has a huge impact on any classification, on any comparison results. nDPI is able to classify about 350 different protocols. Any commercial engines give you something between 3,000 to 5,000 protocols. Why this big difference? There are a few reasons for that, but the key point is that this number is mainly a marketing slogan, because most of these protocols are really only sites. So it's quite easy to have thousands of different protocols when you start adding, for example, the 50 most important sites for every country where you have some customers. For example, an engine has different protocols for the Italy, Corriere della Sera, Gazzetta dello Sport, Repubblica, for all the important banks, for all the important travel sites, Italo, Alitalia, Trenitalia, and so on. I let you decide if these protocols are really protocols application or not. In any case, any engines, even nDPI, allows you to extend the protocols and to define some kind of custom protocols if you are interested in some specific site. No surprises. Here, in the end, we move to nDPI. Otherwise, I will not be here. Why? First of all, because behind it there is a real company which has been using it for more than 10 years. So it's quite unlikely that we will be left alone on keeping the code up to date. We have access to the code, and if you look at it, it is overall quite good, and a lot of attention has been paid to use the best data structures and the best algorithms. We run a lot of tests, and the overall performance of nDPI are comparable to the performance of the commercial solutions. CPU performance, especially CPU performance, are probably the most important key aspect for us. Regarding classification capabilities, nDPI is, in average, as good as any commercial solution, any commercial solution that we have been able to test for some kind of traffic, for example, VoIP or messaging application. It is even better than some of them. For other categories, commercial software give you a better classification, for example, for the VPN. Unfortunately, there are also some negative aspects about nDPI. A significant one is the configuration. In nDPI, you don't have basically any configuration option. Everything pretty much is enabled always by default, and you can't disable it. That's fine if you are building a demo application or if you just started to learn the nDPI API, but if you need something more tailor-made, your only choice is to change the code. To be honest, this situation slightly improved recently. You can now enable, disable every single protocol, and all the features added in the last 2 years are fully configurable, so you can enable them, disable them. There are some configuration parameters that you can tune according to your own needs. nDPI gives you usually 2 releases per year, and no guarantees at all about any API or API compatibility. That means that when you want to update your application, you download the latest nDPI release, you compile or cross-compile your own code, you change the code because you need to update it to the latest nDPI API, and then you can ship the library and your own application. If you do that twice per year, it's not a complicated stuff. However, any commercial solution gives you an update, new releases every week. In the worst case scenario, every 2 weeks. but they guarantees you full API compatibility across releases. That means that to update your production server, you download the latest version, you copy the library in the server, you restart the process, and everything works. From an operational point of view, that is a big difference. The last time that our vendor broke their API compatibility was more than 3 years ago. So we could have updated our code 150 times without touching or recompiling the application. And if we really wanted, we could have done it at runtime live without restarting the process. These two aspects, frequency of the updates and software compatibility, are two sides of the same coin. More frequent are the updates, more important is to have some kind of software compatibility. When we moved our software to nDPI, we faced some challenges. The first one was IPv6. IPv6 is a key feature for us, and generally speaking, nDPI supports IPv6, but there are some core functionalities that don't really like IPv6 addresses, so we needed to extend them. The other challenge was more about how we deploy nDPI. We didn't install nDPI on new server for a new project for a new customer, but we update existing server to existing deployments where we already had years of data and metadata saved on disk that we needed to keep using. That means that we needed to be sure that the transaction from the old engine to nDPI was seamless, transparent, not only to the client, okay, but also to any application using, reading, or writing the information provided by the DPI module. For example, we had to keep the same protocol name, the same protocol categories IDs, the same metadata format and semantic. All the application configuration needs to keep working even after the update with the same semantic. That was a little bit tricky since nDPI don't give you any configuration option in the time. Okay, last but not least, let's talk about money. Commercial DPI libraries are quite expensive, they are expensive, while you can use nDPI without paying any fees. However, I think that we all know very well that using or integrating open source project into your own application is not free, especially if you have to update or maintain that code. At very least, you have to pay someone internally or externally to do that kind of work. However, we are sure that in the medium term, the choice to move to nDPI will be the right one, even from a cost perspective. We are going to save money, which is always some kind of bonus. Conclusion. Are we happy with nDPI? Yes. Do we recommend nDPI? Yes. Does it mean that nDPI is perfect? No, it doesn't. Commercial libraries can give you some kind of advanced features or capabilities that you are not able to find on nDPI software. But everything considered, if you ever need a deep packet inspection software, nDPI is definitely your best option in our opinion. Give it a shot. Thanks for your time.